Hey there, welcome to the Explainer. Have you ever opened up a spreadsheet and just seen a wall of numbers? Pure chaos? Well, today we're going to look at two super simple but really powerful tools that can take that mess of raw data and turn it into something that actually makes sense.
Yeah, we've all been there. You get a report, and it feels like you're literally drowning in numbers. And when you're just staring at a wall of digits, it's pretty much impossible to spot any kind of trend or, find any real meaning in it.
Okay, take a look at this. These are the ambulance transport distances, in miles, for 60 different patients. The numbers are all over the place, from 1 up to 47. Just by looking at this jumble, could you tell me what a typical distance is? Or say how many trips were more than 40 miles? No way! It's just raw quantitative data, and right now it's not telling us a story, at least not yet.
So how do we fix this mess? Well, the first tool we're going to grab is the frequency table. This thing is a classic for a reason. It's a fantastic way to summarize data and bring some much-needed order to all that chaos.
And just to be super clear, the tools we're talking about today are made for this specific kind of data, quantitative data. We're dealing with numbers you can measure, right? Things like age or heart rate or distance, not categories like gender or a diagnosis.
The very first thing we have to do to build our table is create some buckets for our numbers to fall into. Now, in statistics, we call these classes, but really all it is an interval, a range you decide on, like 30 to 39 miles.
Okay, so once we have our buckets, our classes, all we have to do is count. Frequency is just the fancy word for how many of our data points land in each specific class. It's basically a head count for each bucket. Simple as that.
So the whole process is really straightforward. First, you decide on your classes, your buckets. Then, you go through all your data and just tally up the frequencies for each class. And finally, you put it all together in a nice, neat table.
And boom, look at that. Isn't that so much clearer? That chaotic cloud of 60 numbers is now perfectly organized. We can see in a split second that the most common trips were under 20 miles. That happened 25 times. See? This table tells a story that the raw numbers just couldn't.
And we can even take this one step further with something called relative frequency. All you do is divide the count for a class by the total number of data points, and you get a percentage. This is absolutely key when you want to compare two different sets of data, like, say, this month's ambulance data versus last month's.
Now, frequency tables are awesome, but they do require a little bit of planning up front. What if you just need a quick look at your data, like right now? For that, we turn to another tool that is just brilliantly simple, the stem and leaf display. To really see this thing in action, let's switch to a new set of data. This shows the number of days 42 different patients had to wait between getting a referral and their first mental health appointment. And yep, once again, it's just a list of numbers. Our job is to find the hidden pattern.
The whole idea here is so simple and elegant. Every single number gets split in two. The stem is the main part of the number, in our case the tens digit, and the leaf is just the very last digit, the ones place. Think of it like a plant. You've got the central stem and all the individual leaves are branching off of it.
And get this, building one is so fast. You just draw a vertical line, take your first number, put the stem on the left and the leaf on the right. Then you do it again for the next number and the next. There's no pre-calculation, you don't have to define any classes. You just build it as you go.
Let's just walk through a few. Okay, our first number is 30. So the stem is 3 and the leaf is 0. Easy. Next is 27. So we start a new stem, a 2, with a leaf of 7. The number 12 gives us a 1 stem, and 42 gives us a 4 stem. You literally just keep doing that for every single data point. So after you've gone through all 42 numbers, this is what you've got. It's a full picture of our data, which is great, but notice the leaves on each stem. For the 30s, we have 0, then 5, then 8, 6, 5. They're all out of order. This is what we'd call an unordered display. But here's where the real magic happens. With one tiny extra step, you just order the leaves on each stem. So look at that 3 stem now. 0, 5, 5, 6, 8. All of a sudden, the shape of the data, the density, it all becomes so much clearer. It's amazing how powerful that one little act of tidying up can be. And that brings us to what I think is the most important takeaway here, the secret connection between these two tools. So let's just put them side by side. The frequency table, super structured, great for formal reports, but you have to pick your classes before you start. The stem and leaf display, incredibly fast, zero pre-planning, and it gives you an instant feel for the data's shape. They seem like totally different ways of doing things, right? But here's the pro tip. They work together perfectly.
You can use the quick and dirty stem and leaf plot to help you build the more formal frequency table. I mean, think about it. Once you have that ordered stem and leaf display, counting the frequencies for your classes becomes ridiculously easy and accurate. The fast tool makes the powerful tool even better.
So, why do we do all this? Why even bother organizing the data in the first place? Well, it's all about seeing the underlying pattern, the bigger picture.
Whether you use a frequency table or a stem and leaf display, your goal is to reveal the data's shape, or what statisticians call its distribution. You can literally see where the data bunches up, where it's sparse, and if there are any weird outliers.
And that's the whole point. As statistics lecturer Monica Wahi puts it, the purpose of both of these things is to reveal a thing called a distribution. You are literally transforming a messy, meaningless list of numbers into a visual shape that has meaning. And that really is the key takeaway, isn't it? These tools aren't just about making things look pretty or neat. Organizing your data is the fundamental first step to actually understanding it. It's how you turn raw numbers into real information. So the next time you're facing down one of those chaotic spreadsheets, you've got the tools to bring it all into focus. But just remember, getting it organized is only the beginning. The real question is, once you can finally see the pattern, what story is your data trying to tell you?